Hello dear students, I hope you're all doing well. So today inshallah we are going to go through chapter 7, section 3, titled Alkenes and Alkynes. Okay, so these are the learning objectives from the lesson, the main ones. Compare the properties of alkenes and alkynes with those of alkanes. Okay, we'll touch on some of these properties. Describe the molecular structures of alkenes and alkynes. Name alkene or alkyne by examining its structure. Draw the structure of an alkene or alkyne by analyzing its name. Okay, so that's the lesson. I really recommend that you go through Alif lessons 65 and 66, especially the videos. The videos are very nicely organized, and they explain the naming system in an interactive way, with also some exercises within the video, and also the check, understanding, and exit tickets, of course. Okay, so let's start with the first lesson. So the first part is going to be about alkenes. We are going to identify and name an alkene by examining its structure. We're going to draw the structure of an alkene or alkyne by analyzing its name. We'll recognize some of the properties and applications of alkenes. So we'll be focusing only on alkenes in the first part of the lesson. Okay, so some hydrocarbons, okay, can make double and triple bonds. So double bond means you have two carbons. Double bond between two carbons. Triple bond means you have three bonds between two carbons. Okay, so alkenes are hydrocarbons that contain at least one double bond. That's the main idea. So the alkenes contain double bond, and alkynes, so alkenes means double bond, and alkynes contain at least one triple bond. That's the main idea of the lesson. Okay, so alkene has a double bond, alkyne has a triple bond, and alkane, which we covered in section 2, has only single bonds. Okay, so the endings are different. So let's start with a quick revision. Compared with its corresponding unsaturated hydrocarbons, a saturated hydrocarbon has it has more hydrogen atoms. Okay, and saturated hydrocarbons are alkanes. Okay, single bonds. Unsaturated can be alkenes or alkynes, so they have less hydrogen. Okay, so these have less hydrogen, and saturated mushabba means they have more hydrogen. Okay, we saw this in section 1. Okay, so again, this is a quick revision on what we saw on section 1. We said hydrocarbons can be saturated and unsaturated. Alkanes have single bonds, alkenes have double bonds, alkynes have triple bonds. Okay, now this is again a quick recall on the single, double, and triple covalent bonds between carbons. Okay, so you can see this is methane. Okay, we already know it. This is ethene. Okay, and this is ethine. So remember, if I had something like this, only single bonds, this will be ethane, right? See, when I have a double bond, I only change ANE to ENE because it's an alkene, double bond. And if it's a triple bond, we'll change the last part to YNE from alkyne, and so on. Okay, so what are alkenes? Alkenes are hydrocarbons that contain at least one double bond. So it can have one double bond, two double bonds, three, and so on. Because an alkene must have a double bond, there is no one carbon alkene, because you need two carbons, at least two carbons. Okay, the simplest alkene has two carbons, and its formula is C2H4. Okay, so this is the formula of ethene. So you have a double bond between the two carbons, and each carbon now will have a single bond, right? Because carbon in total can make 4 bonds. So you have 2 here, 3, 4, 2 here, 3, and 4. So this one is called ethene. It's the simplest alkene. Okay, These are some examples of alkenes that you have in your book. These are the molecular formulas. Okay, these are the structural formulas showing the connections, and these are the condensed structural formulas. Okay, so the double bond is between this and this, double bond is between this and this, double bond is between this C and this C, the double bond is between this carbon and this carbon. Okay, so in alkanes we said that the formula of alkanes is CnH2n plus 2, right? What will be the formula of an alkene? So if this is N, this is 2N, right? When this is N, this is 2N. When this is N, this one is 2N. So now you kind of noticed that the general formula is going to be CnH2n. But make sure to understand that this formula is true only for alkenes that have only one double bond. If I have two double bonds, then this formula is not valid. Okay? If you have more than a double bond, then this formula is not valid. So this formula is only true for alkenes with one double bond. And this is what we covered. Okay? You can stop the video, go through this slide. So what's the general formula of non-cyclic straight chain alkenes? It's CnH2n, as we saw. Okay. Now the formula of the following represents. So 1, 2, 3, 4, 5, 6. Remember what's the name of the hydrocarbon that has 6 carbons? You might think that it is hexane, right? But this is an alkane. Now here, this thing here is alkene because it has a double bond. Can you see the double bond? So this thing here is going to be hexene. Okay? And it's an alkene because it has the double bond, all right? So how do we name alkenes with 2 or 3 carbons? So basically, it's the same name as alkanes, but you change A and E to E and E. Okay? So this is ethane. If I have a double bond, it will become ethene. Okay? This is propene because there is a double bond. Okay? How do we name carbons or alkenes with 4 or more carbons? So we need to specify the location of the double bond. So we need to show where does the double bond happen. In which carbon? Is it in carbon number 1, number 2, number 3, or number 4, and so on. So this is done by numbering the carbons in the parent chain. Remember, like alkanes. Starting at the end of the chain, that will give the first carbon in the double bond the lowest number. Then use only that number in the name. What does that mean? So when you give numbers, okay, to an alkene, you should only focus that the numbers are ordered in a way that the location of the double bond has the lowest number. So in here, it's 1, 2, 3, and 4. So you say 1 butene. Why? Because the double bond is between carbon 1 and carbon 2. Which one is lower, 1 or 2? 1. So you're at 1 butene for the double bond. You cannot say 1, 2, 3, and 4. This is wrong because that will give you a number 3, okay, for the location of the double bond. This one here is going to be 2 butene. Why? Because the double bond is between carbon 2 and carbon 3, so you choose the lowest number. Now this thing here we cannot do. So if you number from the left to the right, that gives you the carbon or the double bond to be at carbon 3, so 3 butene. This is wrong. Why? Because I can number from right to left. That gives the location 1 for the double bond. So you say 1 butene. So in alkenes, we need to show the location of the double bond. Okay? And this is what's written here. How to name cyclic alkenes? The same way we name cycloalkanes. Okay? But carbon number 1 must be one of the carbons connected to the double bond. So this is the condition. So it's the same as cycloalkanes, but carbon number 1 should always be the one connected or the one that has the double bond. For example, if we see something like this, you see, how do we name something like this? Let me just show you here. So this is a double bond. Okay, here CH3, here CH3. So how do we name this? Now you might think I might say 1, 2, 3, 4, 5, right? So what are the locations now? So the location of the double bond, which is this one, it was going to be 1. Location of methyl is 2, and location of methyl here is 5. صح? But if I actually start 1 from here, again the double bond is always number 1. 2, 3, 4, 5. What will be the location of the double bond? Is going to be 1. What's the location of CH3? 1. What's the location of CH3 here? 3. Which one is lower? 1, 2, 5 or 1, 1, 3? So 1, 1, 3, okay? 1, 1, and 3. And the name is going to be 1, 3, dimethyl. Okay? Continue. If it was on an alkane, you will say cyclopentane, right? But because this is a pentene, it's going to be cyclopentene, as you can see here. Why pentene? Because we have a double bond. Okay? So how do we name branched chain alkenes? Again, it's the same as naming alkanes اللي تعلمناها في الدرس الثاني, section 2. But the only difference now is that you have two exceptions. Number 1, the parent chain is the longest chain that contains the double bond. So if you have 9 carbon chain, only single bonds, and 8 carbon chain with the double bond, you will choose this one, because this thing contains the double bond. This does not. This is the meaning, okay? That's the parent chain. So the parent chain will be octene, not nonene, okay? The position of the double bond determines how the chain is numbered, not the branches. So you should choose the numbers so that the location of the double bond is the lowest, not the branches, okay? So if we look here, this is the double bond, right? So if I name from the left, the location is going to be 1. So we have 1, 2, 3, 4, so butene, and you have methyl at location 2, so 2-methyl butene. Okay? Now if I have a carbon like this, and a hydrocarbon like this, and I have 2 double bonds, so I have this one and this one, right? If I choose naming from left to the right, the locations are going to be 3 and 5. If I name from the left, the locations will be 3 and 5. If I give numbers, if I give numbers from right to the left, then the locations are going to be 2 and 4. Okay? Which one is lower? 2 and 4. Tamam? So it's going to be 2 and 4 heptadiene. So why did we put di here? Because we have 2 double bonds. Remember, when we have 2 methyls, when we had 2 methyls here, and in section 1 we say dimethyl, right? Now how can we show that we have 2 double bonds? By saying diene, okay? And this is what is mentioned here. For alkenes with more than 1 double bond, you must indicate the positions of the double bond and their number, okay? Like 2, 4 hepta, di for 2, okay? The positions of the bonds are numbered to give the lowest numbers. So in alkenes, we focus numbering on the double bond. We should get the lowest number for the double bonds, okay? So you can go back to in the video, okay, and double check the concepts that we saw. And we are going to start with this example that you have in your book. All right. So name the alkene shown. So you have an alkene here. If they didn't say alkene, you see the double bond, right? So it is an alkene. Okay, very good. So what are the rules? We need to find the longest chain with the double bond, right? So let's see, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So the longest chain is this one, right? Now, how do I put numbers? Do I give numbers from left to the right, or right to the left? Which one will decide? The location of the double bond is going to decide that. So up here, the location of the double bond is 2, right? Down here, it's going to be 5. لأن هي ما بين 5 و 6. 5 أقل شيء. Okay? So we are going to choose the numbering up here. I don't care about the branches. I only care about the location of the double bond. So how many carbons do we have here? 7 carbons. So it's going to be heptene. Okay? What's the location of the double bond? It's 2. So we'll say 2 heptene. Do we have any branches? Yes. We have dimethyl, right? 2 methyl groups. What are their locations? 4, carbon 4 and carbon 6, right? So we say 4, 6 dimethyl 2 heptene. Okay, so 2, 4, 6 dimethyl heptene. If we check the solution, it should give us the same. Okay, so 4, 6 dimethyl 2 heptene. Okay, and that's the solution that you have in your book. 4, 6 dimethyl 2 heptene. Okay, in your book, the steps are mentioned, and they are mentioned here in the PowerPoint, so you can view them at your own time, but I just showed you how to do it in a fast way. Okay, so everything that they mentioned here we already did, okay, but in a quick way. So they say name the alkene with the formula CH3CH2. So when they say it's an alkene, count how many carbons do you have? 3. So 3 carbons is propene, right? Now which one will give you propene here? C and D, right? So these are wrong. There's no cyclo here. It's not a cyclic propene. Now if I want to draw this, how do I know what's the location of the double bond? If I have CH3 here, so this C can make, it's already making 3 bonds with hydrogen, so it can make only 1 bond with the carbon here, right? CH. So CH has a bond here. Okay, the C has a bond here and has a bond with H, so it needs 2 more bonds. So actually the double bond is like this. It's between the CH and CH2, because look, this C has 2 bonds here and 2 bonds with hydrogen, so 4 bonds. This carbon here has 1 bond here, 1 bond with hydrogen, 2 bonds here, so in total 4. This carbon here has 3 bonds with hydrogen and 1 bond with this carbon, so in total 4. So what's the location? 1, 2, 3. So of course we choose the lowest number. So it will be 1 propene. Okay? What's the IUPAC name for the following thing or the following structure? So what's the longest chain? It's this one, right? It's obvious. How would you start numbering? Look at the double bond and start from there. So 1, 2, 3, 4, 5. Now you have methyl here, right? And also methyl here. What are the locations? 3, 3, dimethyl. What's the location of the double bond? It's 1, right? Because look, it belongs to this carbon. So 1. How many carbons do you have? 1, 2, 3, 4, 5. So pentene. Okay? All right. So use the IUPAC rules to name the following structures. These are the problems that you have in page 232. Okay? In your book. So this is the following first structure, and this is the second structure. So let's do this one first. Now, before you watch this part, please try them on your own and then come back and watch the video, okay? So stop the video now and come back when you finish. Okay, so welcome back. I hope your answer is going to be correct. Let's check how do we give a name to this compound. So first of all, you have the double bond, right? So what's the longest chain with the double bond? It's this one, obvious. How do I give names? I can start 1, 2, 3, 4, 5 or 1, 2, 3, 4, 5. Which one gives the lowest number to the double bond? Up here, it's going to be carbon 2. Down here, it's going to be carbon number 3. So this one is wrong, this one is correct. I have 1, 2, 3, 4, 5. So 5 carbons, okay? So the name is going to be pentene, right? Now, I have a methyl group at position 4, so I'll say 4 methyl. What's the location of the double bond here? It is 2, right? So 2 pentene. Let's have a look here. I don't want you to quickly choosing this one always as the longest chain. No, sometimes it's wrong, okay? So look, 1, 2, 3, 4, 5, 6, 7, right? So if we delete this and check again, if I start from here, 1, 2, 3, 4, 5, 6, 7, 8. So if I choose this chain, I have 8 carbons here. Okay? Sorry. No, it's not like that. Wait, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, you can choose it. So basically what you can do it like this, or to make it look visually better, you can start from here, okay? And choose it like this, like L. So 1, 2, 3, 4, 5, 6, 7, 8. It doesn't matter because all of these are CH3s, okay? CH3, CH3, CH3. Now, how do I number? I will start numbering from the location that is close to the double bond. مين أقرب للدبل bond? From up here ولا down? From down. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 is octene, the parent chain, right? Now, I have 3 methyl groups, 1, 2, and 3. What are their locations? So 2 and 2, one here and one here. And this one is carbon. Which carbon is this? 6. So it will be 2, 2, 6. How many methyls group do I have? 3. So try methyl. What's the location of the double bond? It's carbon number 3. مش number 4, number 3 لأنها أقل من 4. So 3 octene. And this is how we name alkenes. Okay, you can check our solutions here. So 4-methyl-2-pentene, 4-methyl-2-pentene, and then 2,2,6-trimethyl-3-octene, 2,2,6-trimethyl-3-octene. Okay. Now, as for the properties of alkenes, okay, خصائص الالkenes, you can also watch Alif Lesson 65, okay, the video. It has a very nice explanation of the properties. So they are non-polar and have low solubility in water. ضعيفين الذوبان في الماء لأنهم non-polar نفس الالkenes. They have low melting point and low boiling points. They are more reactive than alkanes because they have a double bond, a double covalent bond, okay? So they have better electron density and they have higher chemical reactivity. عندهم تفاعلية أكثر, okay? Some uses of alkenes, ethene, okay, which is a hormone. It helps fruit, or it causes fruit to ripen, okay? يساعد على نضج الفواكه والخضروات, especially الفواكه. So, and it causes leaves to fall from the trees in preparation for winter. So in fall, فصل الخريف, ethene helps leaves to fall off, okay, the trees. You know, sometimes when you go to the supermarket, you'll find raw avocados, raw apples. They are not ripened, they are not fresh. But if you use artificial ethene, it will become fresh, and it will not fresh. It will be ripened. Okay, بتنضج. So that's one of the uses of ethene, especially here. So ethene, it will help bananas to ripen, okay, or become ripen, to ripe or become ripen. Ethene is also used to synthesize plastics, plastic bags, ropes, milk jugs, and so on. Okay, all of these are examples for the uses of ethene, which is an alkene. All right, and yeah, that's the end of the first part, which was all about alkenes. Okay, I wish you all the best. Thank you.